Hello, this is David Bates, and this is the RAS team, and this is our EEE 489 Capstone Project first video report. To kick things off, I'd like to talk about the ASU Blue Origin competition that is an integral part of our senior design project. On January 22nd of this year, I traveled to ASU to participate and represent our team in the Blue Origin competition. It went very well, and we ended up being selected as one of the payloads to go up on the Blue Origin rocket in October. So it was a very positive experience from that perspective. The other thing I wanted to report on is the fact that we had a preliminary design review meeting recently where we were deciding on some of the components to be used in our experiment. Part of my part in that was in putting together a proposal for which video camera to use to record as correlation data for the experiment. And we ended up selecting the Mobius Mini Action Cam Pro camera. So with that, I will hand it off to Logan Sisca.
Thank you, David. Now I'd like to talk about the command and data handling subsystem, which consists of the flight computer and the analog to digital converters. So first of all, during the preliminary design review last week, I presented my trade studies for the flight computer, and in the end I selected the Raspberry Pi 3 Model B mini computer to serve our purposes. We found that both its power consumption and computing capabilities make it ideal for our choices. Now, the flight computer will interface with the analog to digital converter via an I2C bus, and it will also talk to the launch vehicle itself via a UART connection. And we'll take both of those data streams and store them on board the Raspberry Pi's SD card. A bit about the analog to digital converter. We selected the Analog Devices AD7993 chip to serve as our ADC. Now this will read the analog voltages from the 12 phototransistors on board and digitize them and then send them to the Raspberry Pi via an I2C connection. Now the phototransistors themselves will be surface mount transistors on the printed circuit board that we are laying out and manufacturing in-house during the semester. And they will measure the light levels from the LEDs on the other side of the experiment box and produce the remote acoustic sensor data that we are so interested in. And that completes the update for the CD8 subsystem, and now I'll pass it on to Roland.
Hi, my name is Roland Lizana. As part of the RAS team, I'm responsible for designing the electrical mechanical portion of the RAS. So far, I've built and designed and built one prototype that was used in the presentation for Blue Origin that David mentioned. Since the presentation, we have also went through the PDR design reviews and re-looking at the design and trying to find more low-cost solutions. The electrical mechanical design must incorporate, mounting the container for the B box or Bs. And then we also have another requirement for using fire-rated material, and there's an EMI requirement, so we have to look at shielding. So up until now, we're going to continue forward to see if we can get something built for both Blue Origin deliverable in April and for demo day. So now I'll hand this off to Bryan Trinidad.
Thanks, Roland, and hello, my name is Bryan Trinidad. I will provide the software to run our payload devices. The code for our payload will be compiled and uploaded to a Raspberry Pi, as noted by Logan. The sensor storage is internal to the Raspberry Pi, while the video data collected will be stored directly to the Mobius camera. The current software architecture will be finalized as the overall payload design is determined. Thank you for watching.